Okay, so welcome to chapter number 13, where we'll be looking at integration. Now, this is actually the reverse process of the previous chapter, which was differentiation. And together, they actually make up a branch of mathematics called calculus. Now, this topic is the most difficult topic in maths, and students find it very challenging, just purely based upon the fact that there's a lot of rules and different variations in the questions. But don't worry, we're going to go through it together, and I'm going to pinpoint some tips and tricks that you can use just to make your lives a bit more easy. Right, so let's look at what a typical integration question will look like. So you can see it here. You see this slightly like kind of S shape, and then in the middle is where the function is going to be, the function we are going to integrate, and then we have dx at the end. This dx just means we have to integrate with respect to x, meaning we just integrate the x terms. Sometimes it might be dy or like ds or dt. That just means we should integrate just the s terms or the y terms or the t terms. But I'll pinpoint it out later on in the videos. Right, so as I said, integration and differentiation are the opposites of each other. So if I have a y equation or an f of x equation, and I differentiate, remember we get dy by dx or f prime of x. But if I have dy by dx or f prime of x, and I want to go back to my y or the function f of x, then I would have to integrate. So that's just the relationship between differentiation and integration. Okay, so let's start off with a very simple function to integrate, and that function is x to the power of n. Right, so as I said, opposite of differentiation. So what we do first is we actually add 1 to the power, so it would be n plus 1. And then we divide it by that power. So if we were to integrate x to the power of n dx, it would be x to the power of n plus 1 over n plus 1. And then we add this plus c constant. Now this c constant is called the integration constant. And the reason it's there is because, let's say I wanted to differentiate like number 5, right? If I was to differentiate 5, remember it just gets 0, it disappears. So this c is there just in case that there was a term that when we differentiated it would disappear. Later on we will be given conditions to be able to find this c value. Now in this specific form, this is known as an indefinite integral, just purely based upon this c value. There are some examples where we don't have to find the c value, in which case it will be called a definite integral. And once again, I'll pinpoint when we are looking at that certain example. Anyway, let's try integrating x squared. So using the rule, remember, we add 1 to the power. So in this case, 2 plus 1 is 3. And then we divide it by that. So integrating x squared will be x cubed over 3 plus the integration constant plus c. Let's try another one. So let's say root x. Once again, changing it into an indices form, that's going to be x to the power of a half. So now we add 1 to the half, so it's 3 over 2. So it's going to be x to the power of 3 over 2 over 3 over 2 plus c, which I can simplify to 2 over 3 x to the power of 3 over 2 plus c. It's very simple. If I was to try and integrate just the number 2, for example, remember, like if it's just 2, you can say it's like 2x to the power of 0, right? Because x to the power of 0 is 1. Add 1 to the power will be x to the power of 1 over 1, so I get 2x plus c. So in fact, if I'm integrating any number, any constant, you just have to add an x behind it. Okay, so let's try some of these questions. So like differentiation, we have to make sure that we have simplified them as much as possible and put them in indices form. So if I was to divide and write it in indices form, it will become 2x to the power of minus 3 plus x to the power of minus 2 plus 3. Now, we just have to integrate each term separately. So let's look at the first one. So 2x to the power of minus 3. We add 1 to the power, so minus 3 plus 1, minus 2, and then divide it by minus 2. So we get 2x to the power of minus 2 over minus 2. The second term, x to the power of minus 2, we add 1 to the power first, so it's going to be minus 1. So it's going to be x to the power of minus 1 over minus 1. And then the last one, plus 3, remember, if it's a number, just times it by x, so plus 3x. This we can simplify to minus x to the power of minus 2 minus 1 over x plus 3x plus c, the integrating constant. Right, let's try this one here as well. This time now we have to multiply out the bracket. So if I do that, I'll get x cubed plus 3x minus x squared minus 3 dx. Let's deal with each one separately. So for the first one, adding 1 will be 4. So x to the power of 4 divided by 4. The second term is 3x to the power of 1. So adding 1 will be 2. So 3x squared over 2. The third term, minus x cubed over 3 minus 3x plus c. Let's just try one more. So once again, let's simplify this as much as possible. So if I do that, I'll get x to the power of 3 over 2 plus 6x plus 9x to the power of half. First term, adding 1 to 3 over 2 will give me 5 over 2. So it's going to be x to the power of 5 over 2 over 5 over 2 plus 6x squared over 2 plus 9x 3 over 2 over 3 over 2 plus c. We can always, or we should always simplify this, so we should get 2 over 5x to the power of 5 over 2 plus 3x squared plus 6x to the power of 3 over 2 plus c. So you can see the actual integrating process is not too difficult. You just have to add 1 to the power and then divide by that power. It's just making sure that the initial form for when you integrate is as simple as possible and written in indices form.